Once again, good morning, everyone. Today I'll be hosting for you first webinar from 10, 11 maybe, depends on my time. And today is my introduction to ArcFlash. It's called ArcFlash Risk Assessment Introduction. So some of you know me, some of you don't. To give you a proper highlight of myself, a bit about me. So I'm a power system engineer. I'm busy with power system studies. Part of those studies are actually big part is ArcFlash risk assessment. So this is something which I specialize in. Today, or maybe you can see the details on LinkedIn if you would like to check more. I have something like 15 years overall experience in electrical engineering, just to give you background. Few words about the webinar for today and for all the next. So we start today with the first webinar out of 10. I try to keep it, at least this one, not very technical. Some of them will be more technicals in details. We keep the time approximately 30 minutes, so I try to keep it short. We have 15 minutes Q&A session. So if you can write questions in the Q&A box would be great. If not, I will try to look it through the chat box. But Q&A is, let's say, recommended. If, as far as I hear, maybe you might see some Polish not translated things in Teams. Sorry for that. I don't have really influence on this, so I thought the Teams is translating things automatically. If not, just let me know and write the things. We'll try to improve it. And yes, I will be recording this and I will upload it into my YouTube channel. So we'll be able to see it later. So what we plan for today, just to give you an idea. Of course, I will explain you what is ArcFlash, actually show you why it happens. We'll discuss some briefly about the statistics, accidents and consequences, and what to do next. So we have 30 minutes, keep in mind it's a limited time, so I'll try to focus on the basic stuff. So let's go through it. You would like to know what ArcFlash is and what is the risk associated with it. The best way to do this, at least in my feeling, is to show you how it looks like. Maybe note this triangle is not just because I found it, it's ISO sign specifically for ArcFlash and shock hazard. So you might see it sometimes on labels and sometimes in fuel. This means ArcFlash. And again, the best way to do this, I will show you. Let me switch it off. This is the video recording in slow motion from Damstra Lab, where I used to actually work with in my Eton times when I used to work in Netherlands in Hengelo. This is a very nice thing to see. If you have a chance to see it live in controlled environment, please do. It's a great thing to do. I'm aware that you might not see everything, so I will play it again in a minute, because I was testing Teams and it was not performing very well. So I will replay it. So you might see a lot of things happening here. If you didn't see in the very beginning, the doors were closed. This is 25,000 amps half second test. Just to give you an idea, it is approx 11 calories for this configuration and this panel. Let me play it again for you. But if you will change, for example, configuration to different one, more personal oriented, not like this by this, it will be called HCB, horizontal circuit breaker. You see, it was closed. I might use this. It was closed. Now it's open. There's nothing inside. It's an empty panel with the bus bar. That's it. And you see a lot of things happening. And I will explain it in details in a minute. So, and the same video you can see here, which is live. Whoa. And I'm pretty sure I have to replay this one again. Whoa. So that's the same video as you can see in the slow motion. So when we discuss about those about the arc flash itself, we always refer to NFP 70, maybe CSA in Canada. I will not discuss it today because we have a planned webinar for it. But just to give you briefly, NFPA, National Fire Protection Association in US, they build a guide for arc flash, generally electrical safety. And they define arc flash hazard as a source of possible injury or damage to health associated with the release of energy caused by electric arc. And what we saw on the video before was electric arc. We initiated in the panel. There is also information known that says that likelihood or is like in the normal words, it would be very small probability for arc to happen if everything is in normal conditions. And those normal conditions are listed, what it means. Generally, everything is okay, then it should be very low probability for arc to happen. So what we saw, I'll split it into the pieces now. So what you saw on the video is big bang, a lot of energy. You don't see it, but if you will stand there, you will feel the heat wave, even 6 meters away. So just to give you an idea what's happening. So first of all, we look on the thermal energy. This is the worst source of injuries that we might have from the arc. And I will show you why it might happen, but if we initiate an arc in the electrical system, it might reach up to 19,400 degrees of Celsius, which is something like 35,000 of Fahrenheit, quite a lot. Just to give you a comparison, on average, it is something around 5,000 to 7,000 degrees of Celsius. There is a lot of different comparisons, but this is a lot. The best comparison you might have is that the second degree burn for your skin is 80 degrees Celsius for 100 milliseconds. And third degree burn is 96 degrees Celsius for 100 milliseconds. So there is a huge gap in between. That's why this is so dangerous for us. So what else you might see? You might hear also about the arc blast, because we have arc flash and arc blast. Blast, as a name suggests, it's something is going to hit you, so which is a pressure related. So this would be a pressure wave that is generated by the expansion of the gas inside, or generally by temperature in enclosure. And then it has to be rapid, it has to be very high short circuit current available for it, not long time, but very intense accident to have a very significant arc blast. And then you might see something like someone, technically there is no recording for it, but you might experience very high pressure, which will drop you away. I think the worst part which might be related with arc blast is the lung damage that you might experience, like the collapse of lung damage and the difference on the pressure between the airs. So that's something which might happen. I think if I calculated recently for something which was at 31,000 amps, half meter away, it was something like 660 kilogram force per square meter. So that's quite a lot. But it doesn't happen all the time. So what's the next? Next, you might see intense light. It's like welding machine. It's very nice correlation. Just welding machine is controlled. This is uncontrolled. If you see intense light, UVA, UVB, how intense it is, it's like 12 million lux, which if you look not today, but in summer into the sun directly, it's 100,000 lux. So that's the 120 times difference. So that's a lot, and you might have a severe eye damage or temporary blindness, or even more, actually. The next thing, maybe you hear on the second video, the sound wave. Sound wave, because it's like thunder from the lightning, is the same. It's very loud, up to 160 decibels. And as a comparison again, about 140, we might have air damage. So that's why we need a protection again. But those are not deadly things. Thermal energy is something which can be very deadly for us. Next thing, molten and solid metal parts. So this, because our system, our switchgear is built with aluminum or copper and also steel. the easiest thing to melt is aluminum and copper. So if you have an arc fault inside the switchgear, as you saw on the video before, you'll see a lot of those small particles flying all over, like those, blinking things. They are relatively small size, but let's say shrapnel, so the solid objects from the bus bar, let's say, it may reach up to 1,100 kilometers per hour speed, which is a lot, but because they are very small size, usually they are not considered straightforward deadly. You need to be very unlucky to, for example, be hit into the eye, which means that you don't wear eye protection at all. Next thing, which is hot air rapid expansion. So there are a few things related with the temperature here. So temperature itself, the temperature causes vaporization of aluminum or copper, depends what our bus bars are made of, and which means it's expanding 67,000 times. So if it goes from solid state to gas, it will expand, let's say, roughly 67,000 times, which means from 1 liter of copper, you might have 67,000 liters of copper gas, let's say. This is approximation, of course, but you might have an idea how big it will be if this will expand inside the enclosure, inside the switchgear. So because of this, there is also a lot of temperature inside the near the arc, but also there is hot air, in general hot air around the situation, around the arc flash. And this hot air is dangerous because it might create lung damage if you inhale, like do something like this, then you can burn your lungs internally. And this is something which is very bad to cure in general. And long story short, it cause a specific design of helmets and PPE, and that's why we sometimes have to wear some specific PPEs like balaclava. What else? I think the only one that left is toxic fume and gas. This is not exactly related with the arc itself, but it's more related with how we build switchgears, how we build equipment. There's a lot of plastic isolation materials, metal, I don't know, paints inside. So the video that you saw before was empty panel. There's nothing inside there, almost nothing. And you still see a lot of gases, a lot of fumes. So that's why you have to be careful about it. So why it happens? That's a good question. And there are no specific, let's say, one source of those sources that you can find, and statistics say, okay, everything happens because of human error. As far as I see, I saw numbers between 30 to 70%. It's not depend on country, depends on place, but human error is a big part of it. It's not 99, 95%, but let's say it's 30, 40, 50% of accidents. But you also have things like wrong work culture or bad organization of work. They are different, to be honest, because you might have perfect organization of the work, but no one is doing it well, or you might not organize it very well, but people are doing it very well. So those are two different things. Of course, you might have wrong tools, and this is also kind of related with the organization and culture. However, we talk about installation tools for work in near or on electrical equipment. Very common things. Poor installation quality of craftsmanship. So generally you might have a panel which is built not well, so the quality is low. Exposed electrical parts, like for some people which are not electrical, you might see that, let me check, you might see that here, those are not fuses. This is a copper bar, never should be like this. So this is not okay. Like besides this, of course, water, dust, so generally mess. This is what we try to avoid when we talk about electrical installations. Corrosion, loose connections, so everything, all the reasons actually why we do infrared scanning. That's behind it. So we try to avoid before it will happen. You might have cable insulation defects. So like probably you don't see it, but here is a damage, puncture damage between the high voltage cable and the other one coming in. Shouldn't be like this. The reasons are multiple, like overvoltage from lightning, for transient recovery voltage, and so on. You might also experience mechanical damage. Might be anything. You know, the animal might hit it, vandalism, whatever, overheating. So that again, that's why infrared scanning is important, or generally permanent temperature monitoring. Poor or no maintenance, a very typical thing to see. And animals, earthquakes, water flood. Depends on your regional locations. You might experience different things. So like in Poland, we expect more water flood than fire and maybe fires, but water flood. But in other, like Hong Kong now, the earthquake, you will see a lot of mess around. So like termites here. So what we expect. So those are the sources. We know what's happening. We know more or less why it might happen, and what is happening actually at the end. What are the consequences? First thing you will see is damage to installation. And I'm showing you this because there will be a damage to installation. You can take it as a granted. If there will be arc flash, there are some solutions to avoid it, to prevent it, of course. But let's say in 99 out of 100 installations, there will be a damage, smaller or bigger. Like this was a panel board, it's completely destroyed, there's nothing to do with it, just to exchange it. Like CT or VT, again, this is to throw away, probably whole compartment has to be replaced or retrofit. Like this bus duct, you see how much energy it is that you have burned from copper and steel, which is 1600 degrees to melt steel. So it's a lot of energy. Like this medium voltage switchgear, this is completely wasted and it has to be replaced. So I'm showing you that there is a damage to installation because we are focusing actually we are focusing all the time on human safety. So we know that there will be a damage to installation when the arc flash will happen. And because of this, we focus on preventing injuries to people. At the second step, we try to prevent damage to equipment if that's possible, to limit it to the very minimum. And because otherwise, sometimes it might escalate, and like this. Those are two examples, but there are much more. What you very often hear, electrical fault, electrical fire, is actually arcing fire. Because normal short circuit faults in the system, they don't create the fires. As again, this I will explain a lot of details about it in the next webinars because they need some proper attention. But you will see like this. Prof in Poland, there was a company, they have electrical fault and the whole facility was burned. So approx 65 million euro loss. And I found also recently was in Ocado, Ocado warehouse in Andover in UK, also had electrical fault in the battery charging unit, lost 110 million pounds. But interesting point was that they indicated the cost of firefighting, which I never saw before, which was above 130,000 pounds. It's quite a lot, to be honest. More than any probably preventing equipment that you might use before this happened. So again, we talk about now the installation damage, equipment damage, but most important for us are injuries to people, human health and safety. So there is something called ESA guide. The whole name is ESA Guideline for the Selection of Personal Protective Equipment when exposed to the thermal effects of an electric arc. It's a very long name. But they did one interesting thing inside. They took some 60 cases from late 90s in Germany from the accidents, and they tried to evaluate it. How are the injuries statistics? What is the most injurious part of the human body? And surprisingly, let's say those are hands and head, which is, this is not a big surprise for anyone if you see people without gloves, without helmets in field. So this will be very typical, to be honest. And but there is one interesting note inside which makes sense, that the surface of the body, the big surface of the body, which is torso and legs, is something which is evaluated or treated as the biggest source of possible fatality. So if you have a big surface, then the more fatal it can be, which I will show you an example, which is a box score. So again, a content warning, because there will be some let's say, after accidents photos. So if you don't want to look at it, don't look at it. This is the injury of 25 years old man. He was working on the 1,200 volts generator in the shipyard. And then when he was working on it, then he created an arc flash and he was burned. So this is after he was taken to the hospital. This is from the Science Direct, from the medical paper, actually. And he had 16% total body surface burn. So we say not that much. So this doesn't look that bad, especially his right hand was bad. But when it starts to heal, it doesn't look that good anymore. So you will see something like this, and this is very bad when it starts to heal, when our body is starting to heal. What I mentioned, so I will not torture you with this, but I will mention that the surface of the body makes a big difference. So this is something which is called Bach score. There are multiple ways actually to calculate it. I took one which is adding +10 extra value for the inhalation injury, which can be also +17. So long story short, the older you are and the bigger the surface you have, then of the body burn, then it is more likely that you will die. And for him, which he's got 16% and approx 25, it was very high that he will survive this, and he did. But you know, if I will be in his place, and then still in this one, but it depends. It's changing during your time and your age and the percentage of the body. So you might see at some point it's quite low to survive such accidents. And about an accidents, this is interesting one. I hope you can see the video. Some of them are nice, like this one. There will be slow motion in a minute. So overhead line work, you might see that not everything was okay. That, as far as I know, that was accidentally recorded when they made the news. So, but still nice video to show you an example that it might be a surprise for the utility workers, even if they are prepared for it because they have PPE for it. The second one is probably this one I have to replay. So you might see that probably there was done some maintenance, some testing, some new job. As far as I look at the video, because it's not the best quality and I have no idea what was the background, I dig out it from the YouTube, and you see this man, I think he's got the face shield down, this one not. Even he's got the, I believe that he's got some gloves. So there you see that they are preparing something. So again, there was something, but not everything was in place. Why? How this can end? From legal consequences. So in general, depends on the country now you are in. You might see that some people are, some countries are more strict about it. It's like in US, where you expect it's more strict, but it's actually not. In US, there was 2019 Van Drechtlekoop, the paper product manufacturing. So they were fined $300,000 roughly dollars for multiple violations, including a near miss on arc flash. It's quite a lot, much more than anything that will prevent it. Again, last year there was an accident in Australia. I have a name of this company, but it was a relatively small company. So they sent two guys, apprentices, to work, 21 and 15 years old, and they supposed to replace the breaker, and they did try to do it live. So he removed the breaker, the older guy, and he tried to fix the other one, the new one, but it didn't fit. So he tried to do something with the pliers, and it didn't work, and he created arc flash, and they were actually severe burn. So you see, like, was 150,000, like 200K. I didn't know that you can get the discount, and they also fined the company director 15K. And so, as far as I know, it was a relatively small company for it. Interesting point was that I dig out the report from Equinor from last year, actually 2 years ago, when they actually had an arc flash accident, crashed aside. There was no information about any fine. I haven't found it, but I know that they estimated the cost on 800,000 euro generally as a cost of the fault and equipment and everything else. And UK recently became much more strength on it, and so they give a lot of fines related with the turnover of the company, as far as I know, and this was near miss in the AVE, which was £660,000, quite a lot as for near miss, I would say, but comparing that someone could die next time, it's I would say good direction. So again, cost on accidents, and this is just to briefly explain that these things happens, and in UK they estimate between 10 to 15 million US, they estimate 10 to 15 million dollars per accident. In practice, you have multiple things that might happen. Life loss, which is the worst case situation that might happen. I might add, because from shock hazard point of view, there are much more accidents and fatal accidents. And I digged out last week reports from Poland, and apparently for shock hazard fatal accident in my country, the fine is like €400. It's extremely low. I don't know why it's like this. So I will have to investigate this and check. Of course, it's not fun. It's just, bittersweet, strange situation. Health and injuries. So again, it depends where you are, depends how the health, medical insurance and expenses are related with the cost of the company. Equipment damage, as I showed you before, anything, depends what's happening. Repair costs, because it can be brand new installation that was already damaged. Power loss, so downtime and production cost, service related costs. As an example, I can tell you that like in data center business, when I check, they have like over $5,000 per minute of downtime, so 300,000 per hour. And I dig out that it was BMW accident, and they were down for 2 or 3 hours, and it cost them, I think, €2 million or something. So depends on the business. Social costs depends on country. Like in Poland, we have a lot of things included in public expense. In US, you have to pay for it. Insurance rate increase. This is something which I'm investigating, because definitely you will have increase, but how big it is. And reputation loss. A reputation loss at the end might lead that no one wants to work for you anymore. So, statistics. Again, in Europe, no one is really tracking arc flash burns. So this is in one big box with electrical hazard. 77,000 accidents in 2017. That was the last one I checked. Complete survey, a lot. And this is only in the workplace, because there are much more in the domestic installations. In US, for example, 2019 latest release from Electrical Safety Foundation, as far as I see on the official data, 1,900 injuries and 166 fatalities. And those are total, including electrical shock hazard. And it's good to know that electrical shock is still the worst one for us. But interesting, as I said, as an example of electrical damage, you see electrical fires. And in US, UK, as far as I see, they estimate about 40,000 accidents per year. And in UK, it was 46 fatalities, as far as I dig in Electrical Safety UK. And in US, 480. So you see there's a big difference. There's much more people dying from it, actually. That's why you will see more often IFDD, arc flash detection device, requirements for residential and commercial installations. Sorry. So pretty much on time, so we will finish what to do next. So that was part of an introduction from my side. As I said, I planned much more webinars, so 10 webinars. We'll be doing this on monthly basis. And I will try to go deeper and deeper and deeper. So the next one is I'll briefly discuss like questions like we have: do I need the study at all? Like what are the conditions that you have to do it? Then in March, I think I planned that what is arc flash study, so a bit more details that you will not see today, because I try to keep this one not very technical, not go into too much details, briefly explain what arc flash is and why it happens. And this will be much more about the arc flash study itself. what we will be doing. And again, project example, how this works from A to Z. So what are the steps, what we have to do. And there are 6 more when I talk a bit more about the PPE selection, data centers examples, some ACFAS mitigation options, how to prevent it, of course, how to solve issues on the project, and an example. And I think few more. It's still ongoing list. So as I said, everything I will be uploading I will upload link onto the LinkedIn. So in my contact details, you have my YouTube channel list, but also I will upload this on my YouTube channel so you can see the recording. So now we have a time for Q&A session. Let me start. I will see if you have any questions. Let me check first Q&A. Okay, so you can see this. Martin, could you please share with us the switch plan as per your experience? As I know the company has in the place the switch plan, how it looks like according to your experience. Switch plan better to be in Lotto permit to work, or additional document attached in the Lotto permits to work better? Okay. Well, technically there is in FPA, I don't know if you're aware, I'm just saying about the source because I don't have one fit to all switch plan. There is NFPA 70B, which is a document about the maintenance of equipment, which I think will be very useful. If we talk about the switch plan, so about the conditions, how to, let's say, create electrical safe conditions of equipment. This is also EN 5010, so European norm, which are 6 or 7 steps, and one of them is Lotto. So it's actually preventing re-energization, but this is what we use Lotto for. So yeah, I can send the reference later on LinkedIn because I don't have a list. When it comes to safety, what standard says about use arc flash protection, clothes, helmets, etc. Use only in specific work always. So there are 2 things. Depends now again on the country. Sometimes it's reinforced by law or legally that we have to do arc flash, or it's very hard to escape from it, like in US or Canada or even Australia. Technically, it is in our European norm also. So we have included EN 5010. This is a standard that it says about the arc flash as a general document. And then we have local standards which sometimes refer, sometimes not, like array code, NEN 3140 in Netherlands, or NFC 15 in France, and more. And when to use it is a different story. So there is an FPA 130.5C table, which it's called likelihood table, which it's kind of a risk assessment behind it, when you estimate when it's more likely for arc flash to happen, and this is a situation when we need to use it, when you need to use PPE. Of course, before we need to calculate if our energy is above 1.2 calories per square centimeters, which is a more than 2nd degree burn. But if we know it's above 1.2, then we need PPE. We need to match PPE. Again, I will make a webinar how to match PPE, about the PPEs, everything else, and the standards, and in a bit more details. And then you can decide, okay, yes, we need PPE. No, we don't need PPE because of energy. Arc flash PPE, I said. And about 1.2, you said how big. So we match PPE with the energy, and then you match PPE with the activity. So for normal operation, most of the time you don't need PPE. There are a few, 2 maybe cases when you need. And for a lot of other things, when you do with live equipment, to make it easier, but it's like just my summary to make it easier to understand. Everything which is live and it's you can touch live exposed parts like bus bar, breaker, or connectors, and you have more than 1.2, which would need from you using arc flash PPE. This is like very simple rule of thumb, I would say. What else? Could be the arc flash because of also wrong installation, because of wrong dead test. Yeah, so that testing or proof that's what I think what you mean is about testing installation for absence of voltage. So at this moment we don't know if there is an absence, if there is voltage or not. So we might create a fault in the system, and then we can create. Question is if your tester is good, because if your tester is bad, like very simple, not related, not adequate, not wrong tools, that I would say, not proper category for measurements, it might be itself a dangerous equipment for you. So this is something which you have to keep in mind, that if you're testing something, you measure something, your tools also has to be proper for the voltage, and also need to have a proper category for measurements for over voltage. Here it's in Poland, minimum PPE requirements for electrical work, how many calories? There are no minimum, let's say minimum PPE is generally 4 calories, but they don't test it less. But in practice, there are no minimum requirements. So in Poland, we don't have like official document which will say, okay, we just need 4 or 8 or 12 calories as a minimum. You just do it as part of your electrical safety plan, based on your risk assessment, based on your evaluation. Do we have any? Do we go proper way? That's I see something on the chat. Okay, let me go from down up. What percentage of high voltage switchgear arc flash accidents are related only by partial discharge? Hard to say. I don't know the value about it. At least I haven't seen any information about it. Thanks for the useful info. Okay, you're welcome. Do you explain arc flash chamber designs in upcoming videos? I might look at it. I don't have it. I assume that you talk about the breaker chamber. I assume this. Can you provide the materials? There was a plan for it to use PowerPoint PPE. I probably have to upload the materials somewhere. Normally I don't, but there will be a video recording. Short videos URLs. I may find it on. I should have it somewhere on the list on the YouTube. So I should upload it somewhere. Are the videos free to use? Hard to say. I try to I don't earn money on it, so. And I think that's it. Do we have any more questions? So time is almost 3 minutes to go. I think that's it for today. So from my side, I might add that this is briefly introduction. I will explain much more details in each webinar. That's because this topic is very relatively long, and if we fit it into one webinar, probably it will be too long to handle. And so I divided into multiple webinars topics, where we also talk about arc flash mitigation, but also about the switchgear design and how to mitigate, how to use the typical solutions. So bear with me. Look on the LinkedIn. I will upload soon next meeting invitation, next event. So thank you all for coming today. I think we have like 1 minute left. So thank you for your attention. Thank you for joining me today, and I hope it was useful for you. And we'll see soon next.